Okay, we are going to continue with the next slide now. We're discussing about measured number, and in the meantime we were also discussing some of the physical properties. One of the examples, just to refresh your memories, we were discussing about density. Physical property can be calculated as ratio of mass over volume. So we're going to do some calculations related with density. In the previous video, I was showing you how to use directly this formula, which is density is mass over volume. Now we're going to see the next relationship. Let's say that if volume is given to you, and also density is given to you, and you will be asked to calculate the mass. Okay, let's say that the volume of the substance would be, we can pick ethanol or acetone, some kind of organic compound that has let's say that it has a volume of 25 grams. I'm just picking the numbers here, and then the density would be like 0.71 gram per milliliter. All right, and then we'll be asked to calculate the mass. So if you look at the previous formula, density is equal to mass over volume. Mass can be calculated as density times volume. This can be a very appropriate formula to solve this equation. So we basically substitute the numbers that we have here. So the density is 0.791 gram per milliliter, and the volume is 25 grams. Okay, so we can calculate the mass, which gives us, I'm going to use basically my cell phone here for right now as a calculator. I don't bring my calculator, but we can use the cell phone. But remember that we always have to apply the rules of significant figures. So if you multiply 0.791 times 25, the calculator display will show you about which my cell phone shows me right now, 19.775. Okay, so 19.775 grams, because we're going to calculate the mass. And actually I was making a little mistake here. The volume, let's say that if we have the volume has to be, sometimes the volume has to be expressed in terms of grams, but for the sake of simplicity we can change this into milliliter. So we can have milliliter instead of grams. So what I'm trying to do it here is milliliter will be crossed out by milliliter, then you will have gram, which is the appropriate unit for mass. Now remember that we have again 1, 2, 3, 4, 5 significant figures, but we would like to have at least 2 significant figures because the volume that was given for you was 25 milliliter. So sometimes it's going to be a little bit confusion to round up numbers, but we have here 19.775 grams. If you round it up to 3 significant figures, it gives you about 19.8 grams. This will give you about 20 grams. Now again, we have zeros here. It's a little bit confusion, especially when you have zeros with no decimal points. There are 2 things that we need to make consideration. If you have 20 grams versus 20 grams, okay, in this case it has 2 significant figures. In this case it's very hard to say whether it has 1 or 2 significant figures. Okay, so what we have to do is you have to rewrite the number like 20 in a form of scientific equation or scientific notation. That way we can able to see that the final answer reflects the two significant figures. So we can say 2.0 times 10 to the power of 1 gram. This would be the best answer to write in the appropriate number of significant figure. Okay, I think we did a lot about significant figure and then the calculation density. Maybe we can pick another example. Okay, bear with me. This time, I guess we have to do converging factors. A lot of times, many students will have a problem of doing converging factors. So we're going to do some examples of converging factors. Let's start with a simple example. Say, for instance, we have a weight of, let's say, 25. Oh, sorry. A weight of 25 pounds, and you want to change that into kilogram. Okay, so 25 pounds is a US system. Kilogram is the SI system. SI means International System of Units. So in order to convert 25 pounds to kilogram, we have to use something called a conversion factor. In most cases, a conversion factor will be given to you. Let's say 1 kilogram equals to 2.20 pounds. You have to memorize this. In most cases, to be given to you. But what we need to know here is how you set up the conversion factor. That's very important. So the way how we calculate here is we write 25 pounds, which is a given value, and we set up the conversion factor in a way that the unwanted unit has to be eliminated. So remember that we have a plan here. We have a pound and we want to change pound into kilogram. So our destination is kilogram. So we're going to put 1 kilogram here over 2.20 pound. So the unwanted unit is pound. So pound will be eliminated by pound. So we can do the multiplication and the division, which means you multiply 25 by 1. Obviously, it gives you 25. And then divide that by 2.20, which gives you about, I see on my calculators, 11.36 kilogram. Well, again, you have 4 significant figure, and you like to rewrite this into 2 significant figure because the given value has 2 significant figures. So it's going to be 11.4 kilogram, sorry. And then it's going to be like 11 kilogram because the number can be removed because it is a number which is less than 5. If it is 5, it can be 5, and above 5 can be rounded to the next number. So the final answer will be 11 kilogram. This might be easier and straight and forward question, but there are sometimes some questions require more conversion factors. Okay, so let's look on the next slide, maybe to do some kind of calculation. Let's say that you have oxygen, the speed of oxygen. Oxygen travels in air, maybe like I would say 215 meter per second, right? We want to change that into miles per hour now, but I think I would make this in a different way. Maybe like, let's say that we have 215 miles per hour. We want to change that into meter per second. Now, why I changed this? Now, mile per hour is, like I said, it's a US system of measurement. Meter per second, this is something called SI system of measurement. You know, we have to be always